Okay, sweeties, here's what we're doing. We're looking at chapter 10 and we're working on section 6. We're going to talk about secants, tangents, which we already talked about, and angle measures. So you remember back in the day, we talked about, let's see if I can get my pen to work. We talked about tangents, which goes through just one beautiful point on the surface of the circle. A secant here is going to go through 2 points, and it's going to be a line that extends through 2 points in a circle. So it's not a chord. A chord just connects 2 points in a circle and it's all contained within a circle. A secant travels through the whole circle. It's a line. It continues on after the circle has been completed. So here, let's take a look at this theorem that we have about secants. So if 2 secants or chords intersect in the interior of a circle, then the measure of the angle formed is 1/2 the sum of the measure of the arcs intercepted by the angle and its vertical angle. Right, okay, let's try it again. What we know is that this angle here, this angle 1, is equivalent to half of AB and DC, the measure of arc AB and the measure of arc DC. So in a way, angle 1 is the average of these two. Average of these two, right? 1/2 this, that, and the third. Angle 2 is going to be the average of these blue arcs. The average of these blue arcs. You're going to add the measure of the arcs up and divide by 2. With that given information, we can attack these problems forthwith. We're supposed to find the value of angle X. Angle X is in the position of like one of the angles, angle 1 or angle 2 up at the top that we just looked at. And so what we know is that we can find the measure by knowing the measure of these 2 arcs that are here. This arc here and this arc here. So from that theorem, we know that X is equal to 1/2 the measure of arc RS plus the measure of arc TU. So 1/2 the sum of those 2 arcs. With that, we should be able to calculate this pretty easily, and arc RS is 84 degrees, where arc TU is 130. And I'm going to put our parentheses around because that's still important. And then the sum of these 2 will give me, let's see, 4, 8, and 3, 1, carry my 1, 214. And then 1/2 of 214 will be 107. So X is equal to 107 degrees. All right, that's not too bad. We're going to shrink this out of the way and get started with the next problem there. So this next one, we're also finding X, but we're going to be dealing with these 2 arcs here. But the problem is we're finding X, but we're not given the arcs that we want. I want you to take a moment and just think, what can we do? We don't know what these are. Maybe we could subtract something, do something interesting. Well, here's what my thought is. If I figure out what Y is, because I can figure out Y, because Y will be related to arc CD and arc AB. If I can figure out Y, then I can figure out X because they're going to be supplementary. They add up to 180 because they form a straight line. You see that? Y, let me zoom in a little bit. You see how Y and X, that's not a pretty Y, babies. I apologize. So you see how Y and X form this nice straight line. So I can find Y and then I can find X. So this is still going to work out in my favor. So let's go ahead and get started with that. To find Y degrees, we know it's going to be 1/2 the measure of those 2 arcs, the measure of arc CD and the measure of arc, we'll write that a little bit better. Sorry. The measure of arc CD and the measure of arc AB. Now I'm just going to replace my values there. Then continuing on, I get, when I add these guys up, I get 218. And therefore Y is equal to 1/2 of that, which is going to be 109. But we're not done, right? Because remember, we're not trying to find Y, we're trying to find X. So if I know that Y plus X is going to give me 180, or X plus Y is equal to 180, just by virtue of them being supplementary, I'm going to replace my Y with 109 and figure out what X must be. And I'm sure you guys are quickly doing this problem yourself, and hopefully you get that X is approximately, what is that, 71 degrees? I think that works, right? All right, and so we have another one over here. Let's look at this. We are supposed to find X, and this time X is the arc measure as opposed to x being the interior angle. So let's see what we can do. What we'll do is we'll start off with what we know. We know that this angle here, that 110 degrees, is equal to 1/2 the measure of x degrees, right? The measure of that arc, plus the measure of this arc, kj, which is 97. And so we're going to solve this like an algebra problem because we're good at that, right? So our 110 comes along for the ride. I'm going to, could I distribute through? I'm not going to distribute through. I'm going to be a big time mathematician. Here's what I'm going to do. Well, it's not really big time. I'm going to undo my 1/2 by multiplying both sides by 2. All right, and so when I do that, those 2's cancel out, and this becomes 220. And now I get x plus 97 is equal to 220. And with a little bit of work, subtracting 97 on both sides, I get that x is equal to 123 degrees. So here's a new theorem for us. Theorem 1013 says, if a secant and a tangent intersect at the point of tangency, so here's a tangent and here's a secant intersecting at this point of tangency, right? Tangent here and secant. Then the measure of each angle formed is 1/2 the measure of its intercepted arc. So angle 1 is going to be half of arc AB, and angle 2 is going to be half of arc ACB. All right? So let's check out example 2 in light of what we just learned. We're going to use intersecting secants and tangents to answer the following question. The first one we have is to find QPR, to find the measure of this angle. This angle, according to our theorem, should be 1/2 of this measure of this arc measure, given the fact that this is a secant and this is a tangent. All right, so 1/2 of 148 is going to be 70 something, 74, right? All right, so that's going to be 74 degrees. That wasn't too bad. Let's take a look at another one. Let's see if they can make it hard for us. All right, so arc DEF, that's this one over here that they're referring to. Let me make it plain. So we're looking at arc DEF. We need to find this measure. And this measure is going to be what? Well, we know that this is 64. And we know that if this angle here is 64, this blue arc, this arc FD, has to be twice that, right? So 64 twice 64 is going to be 128. That's this arc here. Trying to make it blue. We'll see. So there we go, it's 128. All right, now that we've got that 128 arc, we know that this arc here, the arc we're talking about, has to be 360, right? Because that's the circle, the whole circle has a arc measure of 360 if we think about the arc measure, right? So 360 minus 128. Does that make sense? And therefore, for this green arc here, for arc DEF, we get 232 degrees. So here, our theorem that we have here is kind of involved, 1014, and I would suggest you draw pictures that would kind of help you remember some of this stuff. But the cool thing is that all of these have a very similar relationship with the arcs of intersection. So if two secants, a secant and a tangent, or two tangents, so two secants, a secant and a tangent, or two tangents, intersect the exterior of a circle, then the measure of the angles formed is 1/2 the difference of the measure of the intercepted arc. So this angle out here, right here, the one that we're talking about, these angles out here, angle A in each of these cases, would be, given the value of DE, arc DE, the measure of arc DE minus the measure of arc BC, divided in half. So the last theorem we had was about sums. When the intersection was inside, it was the half the sum. But now that the intersection, in a sense, of these segments is outside and we're forming this outside or exterior angle, the measure of that exterior angle will be the difference, half the difference, all right? So I want you to keep that in mind. Inside was the sum and the outside was half the difference. Y'all know what I'm talking about? All right, let's see if we can we can apply this new information. So we find the measure of each angle. Here's angle L. This is a perfect opportunity. We know that the measure of angle L is equal to 1/2 the measure of angle arc HJK minus the measure of arc HK, right? So this guy minus this guy cut in half is what we're going to do. All right. So if I know that this one, HK, is 102, then I should be able to calculate with relative ease the measure of the other one. So this one is going to be 360 minus 102. 360 minus 102 is going to be 360 minus 258, right? So 258 minus 102, then I'm going to divide that in half. I know it seems like a lot, but it's not that bad. It's not that bad, babies. All right, so we get 156, right, when I take the difference between those two, and then we're going to cut that in half. Then we divide that by 2, we get 78. Woo, that was a lot. This guy down here is 78 degrees. And I'll be honest with you, like when I look at this angle, like I clearly see that this angle is not 78 degrees, right? But according to the numerical information that we have here, it is correct. So this is a situation where you like see on the SATs, it would be like figure not drawn to scale. So like this is not obviously not drawn to scale. So clearly this can't be 78 degrees in terms of if you were to measure it. But according to the details and the information here, it is 78 degrees. All right, let's take a look at this next one. The measure of angle CD. So CD, arc CD rather, arc CD is this guy here. From here to here. All right, that's what we're talking about. And so what we want to do, given the fact that we've got 56 and we've got 95, we need to figure out how that relates to this guy here. Well, what I know is that 56 degrees is going to be equivalent to, 56 degrees is going to be equivalent to 1/2 the difference between arc CD, right, the measure of arc CD, minus 95. You guys see what I'm doing? This arc minus this arc, it's going to be half of that. So now what I'm going to do, like we did in the last problem, multiply both sides by 2. When I get 2 times 56, I'm going to get something like 72, right? No, I don't know where that came from, y'all. I apologize. That's just some bad math. My bad. The preferred answer is 112. Even people like me make mistakes, big ones. All right, so my fault. So arc CD, right? Arc CD is going to have this relationship. 112 is equal to arc CD minus 95. So I'm going to add 95 to both sides, right? And when I do that, I get 9, 10, 0, carry 1, 207. So the measure of arc CD is 207. And somebody might be looking and saying, well, why didn't you just subtract 95 from 360? Well, because we got arc BD that's taking up some of that space. So arc CD and arc BC here, right, won't give me the 360. It'll give me part of it, and then, we'd be missing out on the BD part. Okay, so that wasn't super duper hard, but it was like, a lot of stuff to know. So this might be a wonderful little chart for you to find. It's in the textbook, but you could also, snap it, screenshot it, whatever you hip kids do. You can, take a picture of it and kind of keep it. So on a circle, here's what we've got. Right in the circle, the inscribed angles, you just got that it's half of the arc. Right? Here, when you have an angle that's inside, it's going to be half the average of the intercepted arc measures. When it's outside, it's going to be half the difference of the intercepted arc angles, right? All right, look, it has been good talking to you. I look forward to answering any questions that you have and chatting you up when I see you. Let me know if there's anything I can do to help, and I look forward to talking to you soon. Take it easy, guys.